Tonight, we're exploring the strange and subtle sounds of space, or rather, the quiet that isn't quite what it seems. Above your head, high above even the clouds and satellites, the atmosphere thins and disappears. Up there, in the yawning dark between planets and stars, you expect silence. You've been told all your life that space is soundless, a perfect vacuum, empty and mute. But that's not the full truth. So before you get too comfortable, take a moment to like the video and subscribe, but only if you enjoy quiet stories like this. And if you're still awake, let me know where you're listening from and what time it is for you. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You drift, not quite asleep, not quite awake, imagining yourself floating just beyond the edge of Earth's breadth, where the sky deepens into endless black. The only thing around you is stillness. But it's a strange kind of stillness. Not mute exactly, more like paused. Like standing in a room just after someone has left, with their presence still hovering faintly in the air. In space, there's no air to carry sound the way it travels here on Earth. No molecules packed close enough to vibrate against each other in neat, compressing waves. So yes, if you screamed in space without a suit, your voice would go nowhere. But that doesn't mean there's nothing to hear. Because space is full of movement, full of energy, full of waves. They just speak in languages your body wasn't designed to hear. Solar flares burst from the sun's surface and ripple through space in invisible tides. Magnetospheres hum and vibrate like tuning forks. Electrons spiral through plasma fields, releasing strange chirps and pops in frequencies that can be recorded, translated, and, in a way, heard. NASA once released a collection of what they call space sounds. They're not sounds in the usual sense, not direct recordings through a microphone. They're captured signals, translated into audio. But when you play them, something eerie happens. You hear things you weren't expecting. A howling wind that never dies down. A deep throb like a slow drumbeat underwater. Pulses and static, like something breathing very, very far away. It's not noise in the chaotic sense. It's structured, patterned, sometimes even rhythmic, and it leaves a feeling behind. Not fear exactly, but a kind of wonder mixed with distance. Like hearing something ancient that never meant for you to listen. One of the most quietly fascinating facts about this vast, soundless place is that space can vibrate, but only in the right conditions. In certain parts of space, dense gas clouds, for example, pressure waves can ripple through matter in the form of sound. The frequencies are far too low for human ears, sometimes taking thousands of years to cycle once. But in theory, they're still sound. The universe has been humming its own song since before we had ears to hear. It's eerie to think that there may be symphonies still echoing from before Earth had oceans, simply too slow or deep to be noticed. And yet, researchers still wonder, if a sound vibrates once every 10,000 years, is it still a sound at all? That's the strange poetry of cosmic silence. It's not true silence, it's unheard music. You begin to sink further now, relaxed into that dark weightlessness. You picture yourself drifting past the moon's pale surface, past the orbits of the outer planets, into regions where the sun is no longer the brightest thing in view. Out here, you float in perfect stillness, but your instruments light up with signals, tiny beacons of activity that your body can't perceive directly. And that's the thing, isn't it? Your body isn't built for this kind of listening. It evolved for birdsong and footsteps, for wind in trees and thunder over hills. You were never meant to hear pulsars spinning or black holes vibrating the fabric of space itself. And yet, we've learned how, by building ears made of metal and algorithms, by teaching machines to catch frequencies too wide, too narrow, too fast, or too slow. We've given ourselves synthetic senses, a way to dip our awareness into alien oceans of sound. Some of them are beautiful, others are dissonant, sharp, even alarming, but none of them are truly silent. There's a story about a moment when NASA played the sound of a planet's magnetic field to a room full of researchers. They weren't expecting anything. It was just data. But when it began, the room went quiet. The air changed because it didn't sound random. It sounded like a presence, not a message, not a voice. Just the feeling that something enormous and slow was breathing nearby. And so you drift on through this not quite silent void, letting your thoughts dissolve into the background buzz of a universe that's always speaking, just not in the way you expect. Somewhere far behind you, the earth rotates gently, wrapped in its own electromagnetic song. You can't hear it, but it's there, just like the strange whispers waiting farther ahead. You keep drifting. Space wraps around you now, not as a void, but as a layered tapestry. Black, yes, but alive with movement you can't quite see. There's a pulse here, not from within your body, but from outside, like a sound with no sound, a presence without form. You tilt your head instinctively, even though there's no up here, no air for echoes, no direction for sound to come from. And yet, you feel something, a tension, a pattern maybe, like your nervous system is picking up on something it was never trained to notice. You begin to understand. In space, you don't listen the way you do on Earth. You don't use ears. You use transformation. Scientists call it data sonification, the process of turning non-audio information into something you can hear. Not for fun, but for meaning. Let's say there's a fluctuation in magnetic fields near Jupiter. It's just numbers, really. A stream of changing values measured by a satellite drifting through the planet's magnetosphere. No sound is involved. But what happens if you map those changing numbers to tones? Maybe high values become high pitches and low values become a deeper hum. Now press play. You get something unexpected, a melody, strange, alien, haunting. Not because Jupiter is humming to itself, but because you finally learned how to translate. This is how we listen without ears. The instruments, not microphones, but plasma wave antennas and particle detectors, collect waveforms, frequencies, pulses, and radiation. We don't hear them directly, but the data they gather can be shifted, shaped, and interpreted as audio. You're not hearing space itself. You're hearing what space would sound like if your body were different. It's not unlike the way a bat hears ultrasound. You know it's beyond your natural range, but if you shift the frequencies down, just like slowing a song until its notes are low enough to feel, you can start to sense the structure, the rhythm, even the emotion. One quietly fascinating fact. The human ear can hear sounds from about 20 hertz to 20,000 hertz. But many events in space, solar oscillations, plasma vibrations, even the spin of neutron stars, operate far outside that range. Some phenomena hum at frequencies lower than 0.001 hertz, a single wave every 15 minutes or more. You'd never hear that with your ears, but you might feel it, the way you feel the bass at a concert in your chest, even if you cover your ears. Scientists call these infrasounds, sounds below human hearing. And while they don't usually occur in space the same way they do in Earth's dense air, the idea helps paint the picture. Space isn't mute. It's just speaking in frequencies that slip past you. You float past the orbit of Mars now, gliding through the soft halo of its dusty gravitational pull. Your mind wanders, and you imagine a machine, not one made of gears, but of light and code. This machine is trained not to see, but to hear. It watches the stars and records their brightness, temperature, chemical composition. Then it turns that data into chords, pulses, rising scales. A star flaring becomes a violin stroke. A black hole eating a star becomes a low, shuddering drone. A comet entering a magnetic field sounds like static, followed by a rising hiss. And somewhere in the middle of this, you hear something else. Not sound, not music, but intent. Not from the stars themselves, no consciousness, no message, just complexity, pattern, something you can't help but interpret as meaning. That's the strange effect of sonified data. Even if it begins as raw numbers, once it becomes sound, your brain starts treating it like language, music, emotion. Even now, as you listen to this quiet narration, your mind is pairing rhythm with meaning. It's what you're built to do. Here's the eerie detail. When Voyager 1 passed through the heliopause, the boundary where the sun's solar wind meets interstellar space, its instruments picked up an increase in plasma density. Not visible, not tactile. But when scientists sonified that data, it sounded like a rising note, thin, pure, and otherworldly. Some described it as ethereal singing. It lasted only a few seconds in playback, but in real time, the frequency change unfolded over days. A tone that would have passed unnoticed unless it had been converted, stretched, shifted, filtered, and turned into something we could hear. Even now, Voyager is still transmitting, still floating, still listening. And somewhere deep in the archives, its data is waiting to be translated into another sound. Maybe one no one's heard before. There's still debate, of course. Is this really sound at all? Or are we just assigning human ideas to things that were never meant to be heard? Some physicists argue that sonification is a metaphor, not a truth. That we're taking electromagnetic radiation and wrapping it in a costume of sound just to make ourselves comfortable. Others argue the opposite, that perception is always metaphor. What you call red is just your brain's way of interpreting a wavelength. What you call music is just physics in motion, layered with memory and meaning. Either way, the result is the same. We've built a new kind of hearing, a new way to sense the cosmos, not with the ears we were born with, but with instruments, with translation, and with imagination. You drift a little farther now, still weightless. The silence is deep, but full of texture. Not noise, but presence. Like a room with someone sleeping in the far corner, something massive and slow-moving, just outside your normal senses. And you realize, maybe silence isn't the absence of sound. Maybe it's the pause before translation. You're drifting deeper now, away from the familiar orbits, away from the warm breath of the sun. Space begins to feel colder here, but not in temperature. Cold in scale, cold in time. Something ancient is near, something massive, not loud, not obvious, but undeniably present. You find yourself approaching the edge of a galaxy's core, where gravity thickens the fabric of everything, where light bends like a ribbon of ink in water. And right at the center of it all, the black hole. It doesn't announce itself. There is no roaring, no devouring thunder. Only a pull, steady, constant, absolute. You hover nearby, impossibly close yet safe in this imagined world. And as you wait, you begin to listen, not with ears, not even with technology, but with attention. Because here, even the silence has structure. In 2003, scientists working with data from NASA's Chandra X-ray Observatory noticed something unusual at the heart of the Perseus galaxy cluster, an enormous black hole roughly 250 million light-years from Earth. When they analyzed the X-ray emissions from the surrounding gas, they detected a pattern of ripples, not visual, not audible, but periodic. These ripples, when interpreted as pressure waves, suggested that the black hole was generating a sound, a real sound, if you define sound as pressure moving through a medium. Of course, the medium in this case was not air, but superheated gas in the cluster's core. And the frequency? About 57 octaves below middle C. A note so low, it takes 10 million years to complete a single cycle. You could never hear it. Not truly, but it's still there, still humming. A voice deeper than anything you've ever known. The deepest known note in the universe. It's one of the most quietly fascinating facts in all of astrophysics. Black holes, which we often imagine as dead zones of silence, can actually create waves of sound. Not by emitting them directly, but by disturbing their surroundings. Their gravity tugs at nearby matter, sets gas clouds trembling, shakes magnetic fields and plasma disks in slow, steady pulses. These pulses travel, they expand, they press outward like ripples from a hand placed gently in a lake. You'd never notice them. Not in 1,000 lifetimes. But scale up your senses, and you begin to hear something almost symphonic. Now, picture the eerie detail. You're standing on the event horizon, that invisible boundary around a black hole where light cannot escape. You wouldn't feel it when you crossed it. There'd be no warning. But as you approach it in this imagined body, time begins to distort. Everything slows. The black hole looms impossibly large, yet somehow still quiet. And within its gravitational influence, matter begins to spiral, forming an accretion disk, a swirling halo of superheated particles. It doesn't crackle or roar like fire. Instead, it whines, hums. It gives off electromagnetic radiation so intense that, when translated into sound, it feels almost alive. Some researchers have taken simulations of these accretion disks and converted their dynamics into audio. What results is unsettling. The tone is constant but warped, like a cello with a broken string, echoing in slow motion. It's not that the black hole is speaking. It's that everything around it is singing in its presence. You keep floating, and the space around you feels thicker now, like honey or glass. Not in resistance, but in mood. The idea of sound here feels more like memory, vibrations etched into the dust and plasma, waiting to be translated. And here's where reflection pulls you under. If a black hole can hum and no creature hears it, if a note takes 10 million years to complete, if a vibration spreads through gas across hundreds of light years, is that still music? Or is music something that needs a listener? Some astrophysicists still debate what to call these sounds. Are they real, or are they only sound-like artifacts? Are we imposing human frameworks onto systems too alien to interpret? And yet, the patterns are there. Regular, predictable, repeating. We're not making up the music. We're discovering it. Slowly, patiently. And only now learning how to listen. You drift farther from the black hole, the deep vibration still trailing behind you like an invisible thread. It's strange, isn't it? To think that in the most remote, hostile parts of the universe, in places that bend light, that end time, that erase matter, there are still patterns, still frequencies, still voices. Voices not made of language or sound waves, but of gravity and fire. You close your eyes, Though out here, it makes no difference, and allow the low note of the Perseus black hole to fade in your mind, not like a song ending, but like the tide slipping away from shore. It's quiet again, but it's not silence. It's just the pause between verses. You're still listening. You've left the black hole behind now, but its voice still lingers, somewhere in your bones, or maybe just in your memory. As you drift, things begin to feel lighter. The gravity isn't pulling anymore. Instead, you're coasting through calmer skies. You pass star after star, then slow as you approach a familiar world, but one you've never quite heard this way before. It's Jupiter, a gas giant swirling with storms, ringed by moons, and crowned by a magnetic field larger than the sun itself. You've seen images, the stripes, the swirling eye of the great red spot, but you've never listened to it. Tonight, you do. Jupiter doesn't speak with a voice, but it hums. Not like a song exactly, more like a Tibetan singing bowl, held at the edge of a cosmic table, struck gently by radiation and solar wind. And that's not just poetic language. Jupiter's vast magnetosphere vibrates when hit by high-energy particles, and those vibrations can be picked up as electromagnetic waves. Satellites like Voyager, Galileo, and Juno have passed through these fields, collecting not sound, but plasma wave emissions, the language of particles in motion. Once sonified, they reveal strange musical textures. Deep whooshes, like the rush of distant wind through stone. Electric pops, like bubble wrap being snapped in another dimension. And faint, rising whistles, like a kettle that never quite boils. One quietly fascinating fact. In 1996, NASA's Galileo spacecraft captured data from inside Jupiter's magnetosphere. When translated into audio, the signals revealed something hauntingly beautiful. A rising and falling tone, modulating in pitch like a theremin being played by ghostly hands. Researchers called it a chorus wave, a naturally occurring electromagnetic phenomenon in space plasma. But it didn't sound like science. It sounded like a choir. Soft, distant, eerie. Jupiter wasn't silent. It was ringing. Imagine standing in a room with a giant bronze bowl, 500 times the size of your house. You tap the rim once. The bowl sings. Not loudly, but steadily. The vibration traveling across the metal, echoing against your ribs. That's Jupiter. The solar wind, made of charged particles streaming from the sun, rushes across space and slams into Jupiter's magnetosphere. The planet's magnetic field bends and stretches, snapping back like a taut rubber band. These oscillations generate radio waves that we can't hear directly, but that ripple in clear, haunting patterns when translated. You're not just observing the planet, you're feeling it resonate. And it's not alone. Other planets hum too. Saturn has its own chorus, deeper, smoother, more like an underwater harp. The Cassini spacecraft recorded sounds there that were described as natural radio dramas. Bursts of crackling, followed by waves of droning silence, punctuated by sudden electronic whistles. Even Earth does this. Our own magnetosphere sings chorus waves. You just rarely notice, unless you're listening from above the clouds. Now here's the eerie detail. In 2017, as NASA's Juno spacecraft made a close pass over Jupiter's polar regions, it captured an unexpected sound, a burst of intense plasma wave activity from the planet's auroras. When translated, the sound came out not as a steady tone, but as a rapid series of high-pitched chirps, rising and falling like birdsong in a glass forest. The auroras themselves, the glowing curtains of light above Jupiter's poles, aren't visible from here, but their effects are loud in this translated world. It was a kind of celestial stuttering, a Morse code sent by lightning storms and magnetic forces, shaped by the solar wind. Nobody fully understands what causes it. The timing is irregular, the pitch shifts unpredictably, and researchers still wonder, is it tied to the moon Io's volcanic activity? Is it connected to Jupiter's layered core? Or is it something entirely unknown, a kind of electromagnetic storm we haven't yet seen up close? You float near the clouds now, imagining what it would be like to descend into that massive, swirling atmosphere, to hear the storms from the inside, to drift through ammonia thunderheads and lightning bolts 5 times more powerful than Earth's. But even if you could fall through Jupiter's sky, you'd never find a surface to land on. Just deeper and deeper layers of gas, compressed until it behaves like liquid metal. And maybe, at the center, silence again. But you're not falling, you're listening. And up here, the song still lingers. The sound isn't music, but it behaves like it. It loops, it pulses, it waits to be heard. Like a bowl that's never stopped ringing. You begin to drift away from Jupiter now, slowly, gently, as if released from the edge of a great vibrating bell. Behind you, its resonance fades, but it leaves behind a strange kind of awareness, a sensitivity, as if your mind is beginning to tune in, not to noise, but to movement. Because in space, movement is everything. And when movement carries energy, and energy travels in waves, it speaks, not with voice or volume, but with patterns. You turn toward the sun now, not to get closer. It's far too bright, too fierce, but just to feel the edges of its presence. Its reach is vast, extending well beyond the planets, shaping the very architecture of the solar system. And most of that shaping happens through something you can't see, the solar wind. The solar wind is a river, not of water, but of particles, electrons, protons, helium nuclei, blown off the surface of the sun and hurled across space at up to 1,000,000 miles per hour. It isn't smooth. It surges and dips. It collides with planetary fields, curls around magnetic barriers, gets pulled into spirals by solar storms. And as it moves, it sings, just not in any voice you'd recognize. One quietly fascinating fact: the solar wind never really stops. Even when the sun appears calm, particles are constantly streaming outward, whispering through the vacuum like a tide of invisible sparks. When these particles interact with magnetic fields, especially Earth's, they generate waves in the surrounding plasma. Scientists record these waves, convert them into sound, and listen. What they hear is strange and beautiful. High whistles, low rumbles, pulses, bursts, sweeping hisses like breathing made of static. Imagine the wind back home, the real wind, in trees, across grass, through open windows. Now imagine you're hearing wind without air. Just raw movement, pure flow. That's what the solar wind is. The sound of pressure without substance. In 2013, NASA's WIND spacecraft captured one such phenomenon, a solar storm's impact on Earth's magnetosphere. The data was translated into audio and played back. The result? A long, low-frequency tremor followed by a sudden rising tone, like an alarm clock wrapped in velvet. The tones shifted slowly, almost as if breathing. Not artificial, not digital. Just the music of the sun brushing its fingers against Earth's protective field. And here's the eerie detail. When the solar wind hits Earth, some of it gets funneled down toward the poles where it collides with our atmosphere. This creates the aurora borealis, the northern lights. But it also creates something else, something quieter. Auroral kilometric radiation, bursts of electromagnetic waves generated by charged particles spiraling down into our atmosphere. These bursts are picked up by satellites and translated into sound. When sonified, they resemble soft, skipping radio static, but layered, like a chorus of tiny signals overlapping in rhythmic pulses. Some say it sounds like popcorn. Others hear bird calls or water droplets in deep caves. You wouldn't hear this from the ground. It's a sound made for orbit, a whisper too high for human ears and too faint to break through the atmosphere. But it's there, above you, right now. The solar wind doesn't move evenly. It comes in waves, sometimes slow, sometimes fast, depending on the mood of the sun. During solar maximum, the sun's surface boils with magnetic storms and sunspots, releasing coronal mass ejections, massive floods of particles hurled outward in violent pulses. These events don't scream, they ripple. Satellites record their passing as subtle changes in magnetic force, then convert those into sounds. The result can be unsettling. A deep rumble followed by a rapid flicker, as if something huge just passed you by, without touching you at all. You don't see it, but you hear the shape it leaves behind. Researchers still wonder, could the solar wind be used to study distant systems? Could we listen to other stars by detecting their stellar winds as they interact with exoplanet fields? The math says yes, but the instruments? Not yet. And so we listen, for now, to our own star. Learning its moods, tracking its heartbeat. The solar wind carries more than particles. It carries timing, structure, a secret language we're only just beginning to understand. You're floating again now, near the edge of the sun's influence. Not near the surface, that would melt you 1,000 times over, but far, far out in the outer heliosphere, where the solar wind begins to thin. Its voice gets quieter here, fainter, but it doesn't disappear. Even this far out, Voyager still records its pressure. The wind has slowed, stretched into interstellar space, but it still carries echoes of solar events from years ago. Like postcards in motion, still arriving, long after they were sent. You close your eyes and listen. There's no air here, no sound in the usual sense, and yet your mind fills with rustling static. You hear a breath, not from lungs, but from a star. A breath that never ends. A whisper that circles everything you know. You drift now beyond Earth, past Mars and Jupiter and Saturn, until you find yourself near Uranus, a tilted, spinning ice giant with magnetic fields that seem to writhe rather than rotate. You're here for a reason, because while the solar wind whispers and swirls what it touches, the magnetic shields of planets responds. And that response is not silence, it's resonance. Each planet has its own magnetic field, a magnetosphere, and when struck by the solar wind, these fields ripple like the surface of a drum. On Earth, this dance of particles and magnetism causes auroras and kilometric radiation, but the same process happens elsewhere, at Saturn, at Jupiter, even at little Mercury, and each world, when struck, sings back. NASA's Cassini spacecraft once flew close to Saturn's poles and recorded bursts of radio emissions. Bursts that, when converted into sound, were eerie, melancholic, like moaning wind through alien caves. Some sounded like whistles rising in pitch, then dissolving. Others like ocean waves breaking on some invisible shore. And then something deeper. A hum that pulsed every 10.7 hours, Saturn's magnetic heartbeat, so consistent you could set a clock by it. Except one day it began to shift, slowly, unexplainably. No one knows why. Saturn's rotation remained steady. Its atmosphere showed no sign of change, but the magnetic hum wavered, as if the planet were dreaming or hiding something beneath its storms. Jupiter, on the other hand, doesn't whisper. It howls. Its magnetosphere is the largest structure in the solar system, stretching millions of kilometers, swallowing solar wind and bending it to its will. When the particles hit, the result is thunderous. When the Juno spacecraft recorded these radio waves, researchers were shocked by the intensity. The translated sounds resembled screaming winds mixed with metallic screeches, as though something enormous were turning in the dark. Sharp pulses, grinding tones, bursts like sonar. It wasn't just noise, it was structured, as if the planet were broadcasting something. But here's where it gets stranger. Jupiter's volcanic moon Io, tiny, blistered, restless, plays a role in this soundscape too. Its volcanoes spew sulfur and plasma into space, which then get trapped in Jupiter's magnetic field. The result? Io becomes a kind of electric violin, and Jupiter's magnetosphere becomes its amplifier. The plasma arc between them generates decometric radio emissions. Weird, spiraling bursts of sound fluctuate depending on Io's position. If Earth and its moon whispered, Jupiter and Io sing to each other back and forth endlessly. Even Uranus, cold, quiet Uranus, adds to the cosmic concert. Its magnetic field is tilted nearly 60 degrees from its rotation axis and offset from the planet's center. As a result, its magnetosphere twists and snaps like a wrung-out towel as it spins. NASA's Voyager 2 passed by in 1986 and caught fragments of that twisted field. The data, when sonified, revealed claps, pops, strange, syncopated pulses like an alien Morse code. It wasn't beautiful. It wasn't loud. But it was alive. You might be wondering, if no one is there to hear it, is it really sound? But that's just the thing. These aren't artificial conversions. These are real oscillations, pressure waves, frequency shifts, magnetic pulsations, the kind of things that would be sound if there were air. We simply translate them from plasma and particles into a medium we understand. It's like tuning a ghost into a radio, and suddenly you realize the universe was never silent. We just weren't listening the right way. Imagine floating near Neptune now. Cold, dark Neptune, the last giant. Its winds are the fastest in the solar system. Its storms darker than ink. Its magnetosphere rotates with a deep, strange rhythm. No spacecraft has orbited it. We've only passed by, brushing our ears against its field just long enough to capture one deep thrum. And even that was enough to say, this planet hums too. Each world hums. Each world has its voice. And those voices ripple out into the void, bouncing off each other, passing like memories across space. You float still between these worlds in the quietest place imaginable. No footsteps, no breath, no breeze. And yet, all around you, you hear it. The subtle grinding of planetary fields, the rhythmic pulsing of magnetospheres, the storm-churned moaning of gas giants. These are not human sounds. They're older, stranger, more honest. And in their untranslatable tones, you begin to feel it, that even silence has structure. Even darkness has a pulse. Even nothing has a voice. You're far now, past the planets, past Pluto, past the icy edge of the Kuiper Belt. There's no solar wind here. The sun is only a pale dot behind you. And yet, there's still sound. Older than the planets, older than stars. You're drifting through the cosmic microwave background, the faint afterglow of the Big Bang itself. It doesn't feel like much. The temperature is just above absolute zero. The light is microwaves, stretched by time, diluted by expansion. But hidden in that light is the oldest song in the universe. In the beginning, when the universe was only 380,000 years old, it was dense and hot, filled with a plasma of particles and radiation. And in that plasma, sound waves rippled. Not sound like we know it, through air or water, but pressure waves in the fabric of space-time, surges of energy moving through a newborn cosmos. Physicists call them baryon acoustic oscillations. These weren't tiny waves. They were vast, hundreds of thousands of light years across, rising and falling, contracting and expanding. Each ripple marked where matter would one day clump together into galaxies, into clusters, into everything. In a way, you are made of those waves. If you could hear them, really hear them, they'd sound nothing like music. Too deep, too slow. But when sped up, when translated, when shaped into something audible, scientists have rendered these ancient waves as tones. They created audio from the fluctuations in the cosmic background and played it back. The result was a deep drone, low and soft, a primordial hum like a breath inhaled by a sleeping universe. It wasn't dramatic, but it was real. The universe, it turns out, began with a sound that shaped time, shaped space, shaped you. Not in silence, but in rhythm. And even now, that rhythm continues. The cosmic microwave background isn't truly static. It has tiny temperature variations, little anisotropies, that ripple across the sky like fingerprints. You float through them now, though you can't feel it. But if your ears were sensitive enough, if your mind could slow time, you'd hear a grand, slow chord still ringing from the birth of everything. A chord made not by strings, but by space-time itself, stretching and flexing in its own gravity. You may ask, why does this matter if we can't hear it with our ears? If it never plays on a radio? If it doesn't rhyme? But that's the thing. Every star that formed, every planet that spun, every molecule that cooled, all of them followed that music. It's not that the universe once had a sound. It's that the universe is still resonating with it, right now, all around you, inside you. You're not just an observer of that cosmic music. You are an echo of it. Your bones, your breath, your brain, they all trace back to those first oscillations, to the great harmonic that poured out into the emptiness and sculpted meaning, mass, memory. In that sense, the universe never needed a listener. It was the listener. And every atom of you remembers. You've passed through the music of the beginning. Now, deeper into the dark, the space between galaxies is vast, a cold ocean of nothing. But even here, you're not alone. Something whispers, softly, faintly, like wind brushing against glass. Between the galaxies lies the intergalactic medium, an almost unimaginable emptiness. But even here, particles drift, lonely hydrogen atoms, a few stray electrons, dust from a dying star a billion years gone. It's a whisper's worth of matter. But it's enough. Enough for sound to exist, not in the way we know it, not in waves that ears can catch, but as plasma oscillations, the ripple of electric fields in a sparse sea of ions. They move slowly. They stretch for light years. They're more like sighs than sounds, but they're real. And satellites like Voyager and Juno have detected them, translated them. Let us listen. What do these cosmic sighs sound like? Not words. Not music, but soft pulses, echoes like distant thunder, crackles like breathing through static. There are recordings of Jupiter's magnetosphere, a ballet of charged particles caught in magnetic fields that sound like whales singing in electric dreams. Saturn, too, emits auroral choruses, eerie chirps and shimmering tones caused by electrons spiraling along magnetic lines. They are not music, and yet they are the music of physics. You drift past them now. In this imaginary journey, you're weightless, voiceless, but surrounded by an orchestra that never stops playing. It's not a song of joy or grief. It's not meant for you. But you can still listen, because space is not silent. It's just slow, sparse, subtle. It raises a question. If the universe is filled with sound, but most of it we can't hear, then how much more is there that we never notice? How many hidden vibrations ripple through us every day? How many frequencies pass through our bodies like ghosts? How many songs of existence play forever, just beyond our reach? In science fiction, alien life often speaks in strange tongues, clicks, chords, echoes. But maybe we've already heard the voices of the stars, the sigh of solar wind, the crackle of cosmic rays, the hum of a black hole's last breath. Maybe we just never knew what we were listening to. Maybe the universe doesn't speak in silence. It speaks in scale, in rhythms too large, too slow, too ancient to notice, unless you stop, unless you listen, unless you dream. And so between the galaxies, you keep drifting, surrounded by whispers no one else hears, in a place that seems empty, but is never truly quiet. You drift now into a vast and forgotten cathedral, not of stone or glass, but of magnetism, particles, and time. There are no walls, no ceiling, just space, stretching out forever. And yet somehow it feels enclosed, resonant, like a place meant for echoes. You've reached what scientists call the cosmic microwave background, the afterglow of the Big Bang. A sound so old, so stretched by time, that it no longer sounds at all, but it was once sound. The early universe was hot, dense, and filled with pressure waves. Literal sound waves rippling through a primordial plasma. These weren't little hums. They were thunderous, low-frequency roars, oscillating through a baby universe only 380,000 years old. But as space expanded, those waves were stretched, frozen, muted, turned into light. And today, we receive them as microwave radiation, a faint, uniform glow that comes from every direction in the sky. It's like walking into a cathedral and hearing the echo of a choir that sang 13.8 billion years ago. And yet, we can hear it in a way. Astrophysicists have sonified this background, mapped its subtle variations, translated temperature fluctuations into sound frequencies. The result? A deep hum, a rising tone, a ghostly resonance that represents the shape of the infant universe. In that sound, you hear the seeds of galaxies, of stars, of everything. You hear the universe becoming structure, not from silence, but from vibration. In myth, the universe begins with a word, a tone, a sacred sound. Maybe that's not just metaphor. Maybe creation really did begin with a note, one that never truly stopped ringing. And even though we call it background radiation, it's really a fossilized echo, the slowest and oldest song you've ever heard. As you float through this chamber, you imagine, what would it be like to hear time? Not a ticking clock, but the groaning of gravity, the whisper of expansion, the soft collision of ancient atoms. Maybe time doesn't sound like a rhythm. Maybe it sounds like pressure, like the long, slow inhalation of the cosmos. There is no air out here, no atmosphere, but sound doesn't mind. It travels through plasma, through dark matter's influence, through fields and forces invisible to us. It just doesn't travel for us, unless we translate it, unless we reach, unless we build instruments, not just of science, but of imagination. You are such an instrument. Your brain can process rhythm and tone, but also patterns, metaphors, and mystery. And in this stillness, this quiet hum from before stars were born, you begin to feel something strange, that maybe space isn't silent. Because maybe silence itself doesn't exist. Not really. Everything vibrates, even nothingness, even you. And so you float, a listening ghost in a cosmic chamber. You can't speak, you can't move, but you can feel. The universe is still ringing, still singing, and somehow you've become part of its echo. Now, gently, you're drifting again. Your consciousness glides toward a planet wrapped in mystery, in beauty, in song. Saturn. From afar, it's a glowing orb with thin, elegant rings. But as you draw closer, those rings stop being lines. They become layers, vast, glittering bands of rock and ice, each pebble and boulder suspended in endless orbit, each one making noise. But how? There is no wind, no air. And yet the Cassini spacecraft, before it vanished into Saturn's clouds, revealed something astonishing. The rings vibrate. Gravitational ripples from Saturn's interior travel outward, and the rings respond. They resonate. It's called ring seismology, a way of listening to the planet's heartbeat by watching how its rings move. You imagine it now, a slow, sonorous rhythm, deep booms from the planet's core, translating into trembling patterns among the icy debris, like a giant harp struck by invisible fingers. Every piece of ring material, a string or a key on a cosmic piano. And there's more. Saturn's magnetic field sings too, not in ways you can hear with ears, but with instruments designed to catch plasma waves and turn them into sound. Cassini captured this eerie song, a wavering electronic choir, a chorus that seems to wail and breathe like a living thing. Some say it sounds like whales, others like radio from another world. But whatever you call it, it proves one thing. Saturn is not silent, it speaks. Just not in any language we've ever known. And now you're within the rings. Each chunk of ice the size of a snowball or a mountain, and you float silently between them. But the silence is an illusion. Every particle collides. Every motion makes motion. The vibrations are everywhere, but your body isn't built to hear them. Still, your imagination begins to convert it all into sound. Soft chimes, distant thuds, the faint crackling of cosmic snowfall. You're inside an orchestra, but the notes are spread across light years, slowed by distance, muted by emptiness. You wonder, what does Saturn dream about? Does it remember the birth of its rings, the moons it shaped from frozen debris? Does it hum to itself those low, slow planetary songs that never leave its atmosphere? A strange calm washes over you. Because here, in the cold outer reaches, where everything should be still and dead, everything is vibrating. In slow, ancient music, in frequencies too deep to feel. But now, as you float within this great wheel of ice and light, you do feel it. A pressure, a rhythm, a vast planetary lullaby. And just before you drift onward again, you realize something quiet but profound. The universe is full of instruments, planets, moons, rings, dust, even you, all playing, all responding, all listening. And somewhere beneath the silent veil of space, every one of them is still whispering. Farther now, you're gently pushed by something invisible, sliding across the edge of Saturn's influence into even deeper space. You don't know where you're headed, but that's never mattered here, because the story is still unfolding beneath your slow, drifting thoughts. Jupiter. It rises like a storm-wrapped god, not a planet, but a churning cathedral of cloud. And as you drift closer, you notice something strange. Brief flickers of light beneath the swirling bands. Lightning, but not like Earth's. This is cosmic lightning. Megabolts, spanning hundreds of kilometers, firing deep within ammonia and water clouds under crushing pressure. You can't hear thunder in space. You know this. And yet, scientists aboard the Juno spacecraft converted electric pulses into sound waves. And the result? A crackling hiss, a violent shimmer, a sound like sandpaper on a radio dial, or the breath of an ancient engine. You float in orbit around Jupiter now, watching its storms boil from miles away. The great red spot churns below, a hurricane older than any empire on Earth, and beneath it, the flicker of another electric flash. If you were in the clouds, you would feel the thunder, not hear it. It would shake you. It would ripple your body like a drum. But even from afar, you sense something primal in it, because lightning is one of the universe's oldest voices. It crackled in the early Earth skies, long before life stirred. It sparked in the atmospheres of Titan and Venus. It's even been seen on brown dwarfs, objects too big to be planets, too small to be stars. There it may flash not in clouds of water, but molten metal rain. Can you imagine? A lightning bolt dancing through iron vapor, echoing through a world with no solid ground. It's not silent, not truly, because lightning always sings with plasma, with heat, with light. And your mind, open now to the language of deep space, hears it as a symphony of sudden brightness, the kind that comes before life, or just before death. And still Jupiter sings in other ways. Its massive magnetic field traps particles and throws them in loops around the planet, generating auroras at its poles that are many times more powerful than Earth's. NASA recorded them. They sound like roaring wind, but stranger, wilder, almost like growling. Jupiter, it seems, has a voice, low, rumbling, full of warning, as if the planet is saying, I am not to be crossed. You float away now, not because you're afraid, but because you've heard enough to understand. These are not just storms. They are memories. The way gas giants speak of energy, the way they remember impacts, the way they warn the universe, I am here. I have power. I will not go quietly. You look back one last time. Jupiter, with its spinning clouds, its unseen thunder, its ancient breath. You didn't hear it with your ears, but somehow you felt it just the same. And as you begin your next slow drift into deeper space, you carry that sound with you, like a pulse, etched in silence. Now, silence again, or something like it. You leave Jupiter behind, like the echo of a forgotten storm, drifting into the dark, toward the realm where even light takes its time. Here, between planets, between fields of gravity and waves of energy, you float in a stillness, so deep it feels hollow. And yet, you know better now. Silence in space is never truly silent. It's only slowed. This is where stars whisper their endings, where black holes hum like tensioned strings, where time stretches like soft rubber and sound becomes memory. You begin to notice something, a faint, distant pulse. Not mechanical, not alive, but regular, precise. It beats like a ticking heart from the center of somewhere very, very far away. A pulsar, maybe? One of the universe's most improbable instruments. The collapsed core of a star that died in a supernova and compressed into something so dense it's no longer a place, but a rhythm, spinning dozens, hundreds, even thousands of times per second, flashing beams of radio waves in every direction, like the lighthouse of a long-dead world. You float closer. You shouldn't be able to. But in this dream of space, distances bend to your attention. And now you're near it. Not close enough to be destroyed, just close enough to feel the beat in your thoughts. It pulses, a slow, firm click in your mind, like the tick of a cosmic metronome, like the tapping of something old and eternal, saying, I'm still here, still turning, still counting. Scientists on Earth have captured those signals. They played them through speakers and heard a sound like nothing else. Tick, 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 tick. So perfect in rhythm, you could use it to measure time, more precisely than any human invention. Some pulsars are even used to create celestial clocks, beacons for space navigation, like ancient stars guiding modern ships. Imagine that. A dead star, collapsed to the size of a city, still helping travelers find their way. Across the black sea of space, you listen longer. The pulsar's sound isn't loud, but it's confident, unchanging, a heartbeat without a body, and you realize something strange. The longer you float beside it, the more comfort you feel. Because this is order, this is rhythm, and in a universe that sometimes seems chaotic, noisy, and silent at once, this steady ticking feels like the truth. Eventually, the pulses fade behind you. Not because the pulsar stops, but because you are moving on, back into the darkness, back into the soundless sound of deep interstellar space. But you carry that beat with you, a reminder that even when things fall apart, they can leave behind something beautifully precise, a mark, a rhythm, a legacy. And so now you drift between worlds, between echoes, between ancient songs and future signals. You do not sleep, but you rest. And in the stillness, you start to wonder, what other sounds are waiting in the dark? Not from life, not from machines, but from space itself. A place you thought was silent, but is, in truth, full of voices. You're only just learning to hear. There's a tone, a whisper so low, you almost miss it. It doesn't repeat like the pulse of the neutron star. It doesn't shimmer like Jupiter's radiation storms. It's more subtle, more stubborn, as if it's been echoing for so long that even space has started to forget it. You focus in, tilt your attention, like a dish searching the sky, and there it is, a frequency below all others, low, slow, droning, almost like a sigh. You've heard of this before. The cosmic microwave background, the afterglow of the Big Bang itself, a whisper from the very birth of the universe. Imagine a sound so old it began before stars, before galaxies, before time even had a rhythm. It's not a sound in the normal sense, but if you could convert those ancient photons into something you could hear, you'd hear it now, a soft static, a hush beneath creation, like the exhale of a universe just born. Astronomers have turned that whisper into audio. They processed the signal, scaled the data, and pressed play. And what emerged was something eerily familiar, a crackling hum, a gentle hiss, not unlike the sound of waves on sand or wind through tall grass. It turns out the beginning of everything wasn't an explosion. It was a bloom, a quiet, expanding breath that filled space with energy and time. You float inside that ancient echo now. The same radiation touches your dreamlike form as it once touched hydrogen atoms. 13.8 billion years ago. You aren't separate from it. You are woven into it. Every atom in your body, every element you've ever touched, was formed from that initial bloom. The frequency you're hearing is the background track of everything you've ever known. And suddenly, you understand something. Space isn't quiet because nothing is happening. It's quiet because it's listening. Every wave, every particle, every silence is a carrier of memory, a carrier of meaning. The radio hums of gas clouds, the clicks of neutron stars, the roar of magnetic storms, the sigh of the Big Bang, all of them, voices in the choir of a cosmos still singing itself into being. You take a long, slow breath, not because you need to, not here in this imagined body, but because it feels right to match the rhythm of something so vast. You feel weightless, but full, empty, but aware. The silence between stars isn't empty space. It's a canvas where physics writes poems in waves, where gravity draws lines and dark matter hums low harmonies. Only black holes can follow. You wonder now if someone else, somewhere across this vast sea, is listening too. Perhaps they hear these same background whispers. Perhaps they feel the same pull toward meaning, toward music in the cold. Perhaps they too believed space was silent until they listened. And so you float on, not searching, not waiting, just aware. Because sometimes the most powerful thing you can hear is not a voice or a message or a call. It's the steady, patient sound of everything still becoming, the background hiss of a universe that never really stopped singing. It just got quiet. And now you know where to listen. You drift further now, through currents of dark that seem motionless, but only if you don't know how to feel them. Because in space, motion doesn't always mean movement. And sound doesn't always need air. It needs structure, timing, vibration. And here, in this deepest stretch between galaxies, you feel something new. A kind of call and response. It's not a voice, and yet it answers you. Maybe it was always there, hidden behind human noise, behind the heartbeat, the electricity of thought, the biological hiss of blood in the ears. But out here, far beyond Earth's atmosphere, beyond the buzzing constellations of satellites and even the glow of stars, the universe starts to speak more clearly. You realize you're inside, a kind of instrument, not metaphorically, literally. Imagine this. Galaxy clusters strung together in vast cosmic filaments, like the tension strings of a violin larger than light years. And gravity? That's the bow. It pulls across dark matter and bends space-time, sending vibrations not through air, but through the fabric of existence itself. This isn't fantasy. It's gravitational waves, real ripples, real sound, moving at the speed of light, passing through everything, including you. You remember 2015, the first time humans heard gravitational waves. Two black holes dancing in a deadly spiral, merging after a billion-year courtship. And what did it sound like? A brief chirp, tiny, simple, almost humble. But in that chirp was encoded violence, elegance, and the memory of entire suns falling into themselves. A sound too deep for eardrums, translated into music by math. Now, imagine how many such dances have happened since the dawn of time, each one sending out ripples in the silence of the void. A concert without audience, until recently. Until now. And you're floating in their aftermath. Your dream self is catching faint echoes from collisions that happened before Earth had oceans. You listen, and for a moment, you think you hear a pattern, not music, but something like it. Mathematical, inevitable, beautiful, and it raises a question that seems too large to answer. Is the universe self-aware? Does it sing because it wants to be known? Or is the song just what happens when matter exists long enough to fall toward itself? Perhaps consciousness isn't the composer of this cosmic music, but just another one of its instruments. You feel humbled, exhilarated, and just a little haunted. Because if the void is singing back, what else might it say when we're ready to understand? The music continues, not with notes, but with events. A pulsar blinking in binary, a nebula glowing in slow harmony, dark matter shaping rhythms we can't yet dance to. The cosmos is composing itself constantly. And you, floating here, weightless and still, are a note in that symphony. A tiny one, but no less important. You begin to drift again. The background hum folds into a deeper silence, not empty, but pregnant with motion. You realize this is not a lullaby. Not exactly. This is the universe telling its own story. A story without words, without a beginning, without a need to end. Just one sound after another, echoing through forever. And in the middle of it all, your breath aligns with the rhythm of everything. You are not listening anymore. You are being heard. The dark around you softens, not because of light, but because the dream, the journey, is beginning to return you home. Yet home no longer feels as small as it once did. You've floated in a vacuum that isn't silent, ridden the soundless roar of ancient collisions, and found that the void, the feared nothingness, was full of motion, memory, and meaning. Now, you are weightless, but not untethered. You are quiet, but not alone. As you drift downward, if downward is even the right word here, you pass through layers of thought, so subtle, so slow, they could only have existed in this state between sleep and science. And somewhere, beneath the hum of galaxies, beneath the echo of stars being born and dying, you find it. The smallest sound of all, the one you've been making since the beginning of this dream. It's not your breath, not your heartbeat, not even your thoughts. It's the quiet resonance of your presence in the cosmos, the vibration that everything that exists seems to make simply by being. Physicists call it zero-point energy, the tiniest flicker of movement, even in absolute vacuum, even at absolute zero. A trembling that never stops, not noise, not music, just being. And so maybe the great secret isn't that space isn't silent, but that nothing ever truly is. Everything moves, everything hums, everything contributes to the great song of what is. And now, you know that you do too. You aren't just in the universe, you're part of its instrument. Your atoms dance with old light, your memories echo through electromagnetic fields. Your consciousness, even here, half asleep, sends ripples into a medium deeper than sound. And the universe feels that. Maybe not like a person would, not in words, not in stories, but in shape, in gravity, in rhythm. You matter, in the most literal and the most poetic sense of the word. The dream is closing now. You feel the cosmic quiet settle in, not the absence of sound, but the presence of peace. There's nothing you need to do, nowhere to go, no question to answer. You are exactly where you are supposed to be. The stars hum in slow circles. The void leans closer. And you fall gently into that soft mathematical silence where time has no corners and sleep waits like a velvet curtain. Your body sinks into stillness. Your breath aligns with the pulse of the dark. Your mind becomes the quietest part of the cosmos. And just before the final drift, you hear it again, the sound you make just by existing. Good night, scientist. The universe is still singing, and now you're part of the song.